Chapter 8, Section 7. Our objective is to learn to calculate surface area. Specifically, how do I find the surface area of prisms and cylinders? Our vocabulary terms will be surface area, lateral face, and lateral surface. Surface area is the sum of the areas of all surfaces of a figure. The lateral faces of a prism are parallelograms that connect the bases, and the lateral surface of a cylinder is the curved surface. So when we're looking at the lateral surface or faces, we're looking at the parts that are not the bases of those shapes. In a prism, you can see we have the net and we have the actual shape, and also the same thing for the cylinder. We're trying to find the surface area, which is the outside area of the shape. So imagine you have a box or a can, and you're trying to find the area of that outside, the packaging. Not worrying about the volume inside, but how much material it's going to take to make the outside. So if we break this apart, we're really trying to add up the area of all of the surfaces. So you could do this by finding each individual area. So you could get 6 and 10 and 6, and then figuring out, okay, well, what's this going to be? This is 5 by 3, so that's 15, 10, 15. And you could add those individual sides together, and that would be just fine. You could do the same thing if you were able to figure out the length of this, which would be the circumference of the circle. So it takes a little more effort when you're working with a cylinder. But there's a formula that's been written out to help us do this a little bit quicker maybe. And it goes like this. 2 times the area of the base. There are 2 bases in every prism. So in this case, it's the squares. There are always 2 bases in every cylinder, the circles. So we need the areas of those 2 bases, which are going to be identical, plus the lateral surface, which is all the way around the outside of it. And in the cylinder case, that would be this area here. So we are adding those together, and we can do that using formulas. So we have 2 times the area of the base. Remember, B stands for base area, plus the perimeter, because we need to know the perimeter of the lateral surface, or the circumference. So we're looking at that perimeter times the height of the shape. So that's what all those letters stand for. So we have the area of the base, which is familiar from when we did volume, plus the perimeter multiplied by the height. So remember order of operations, if we were to group these, we need to do the multiplication pieces first, and then add them together at the end. You can see for a cylinder, our formula looks a little bit different, but that's because just like with a cylinder for volume, we know a cylinder will always maintain the same shapes with circles for bases. So to find the area of the base, it's pi r squared, but we have 2 bases, so we multiply it by 2. And the circumference is 2 pi r, or pi times diameter, times the height. So these formulas are the same. This has just been broken down specifically because we know they are circles. So let's try it out. Find the surface area of the following figure. A rectangular prism with a base 4 centimeters by 5 centimeters and a height of 6 centimeters. So I would start by trying to draw out a little bit of an image for this. Now I'm not good at drawing 3-dimensional objects, so I don't really need to. But I want to focus on the base. So I have a rectangular prism, so I have a rectangular base that is 4 centimeters by 5 centimeters. If I remember the formula, surface area, 2 times the area of the base plus the perimeter of the base times the height. So first I need to find the area of the base. Well, that's 4 times 5, which is 20. And then I need to find the perimeter, which would be 4 plus 4 plus 5 plus 5, so we get 8 plus 10, so 18. So now let's use that information. So I have 2 times the area of the base, which is 20. So I have 2 sides that are 20 square centimeters each, plus the perimeter of the shape, based on the perimeter of the base, is 18, times the height. Now the height is of the shape itself, not our 2-dimensional, but our 3-dimensional, and that comes back to the problem, so our height is 6. We do these in pieces. I do 2 times 20 to get 40, I do 18 times 6 to get 108, and then I would add those together to get 148. Now we're back to doing area again, so even though it's a three-dimensional shape, we're still talking about the area of the outside panels, so we would do centimeters squared. All right, let's see what we would do if we have some visuals. Find the surface area of each figure to the nearest tenth. So we are looking at a triangular prism. So when we go to find the area of the base, 2 times the area of the base, so we're going to have the 2 out front. The area of the base would be 7 times 6, because that's the height of the triangle, times a half. And what you'll notice is the half and the 2 are really going to cancel out. And then the 21 comes from the perimeter of the base. So the same thing you found the area of is what you find the perimeter of. So we have 7. The 6 is not part of the outside. And how do we know the rest? Well, we look at the other end. The other end shows that they are all equal sides. So this is 7, this is 7. So 7 times 3 is 21. And then 10, we only use that number once, and that is the height. And you might be thinking, well, that's on the ground, that's not a height. That is a height because it's the distance between the 2 triangular bases. So when we multiply 7 times 6, we get 42, and then we get 210. Add those together for 252 square centimeters. Take a look at the next one. Same idea. So identify where the base is. I see a triangle, so I have the base of 8 and the height of 3. And then if I need the perimeter, I have to look at my individual sides. So I have 8, I have 5, and then looking at the other end, they would match up. So that would also be 5. So I get 8 times 3 times a half because it's a triangle, but times 2 because there's 2 of them. So it's kind of counterproductive here. We just end up canceling them out anyway, but that's following the official steps. And 18 comes from 5 plus 5 plus 8, which is the perimeter of the triangle. And then 10 happens to again be the height between the 2 bases. So we multiply each part. This cancels, so we get 24 plus 180 for a total of 204 square feet. Again, it's square feet because it is area. Let's try a couple cylinders. Now our formula has changed, but remember the reason it changed is because it's 2 times the area of the base, and it's a circle, so it's pi r squared, and 2 times the perimeter, or sorry, not 2 times the perimeter, perimeter times height. It's a good idea to reference your equations. Perimeter times height, and perimeter in this case is like circumference. So we just need to identify radius, which is 15, and the height of the shape, which is 3. Cylinders are kind of nice because we don't need as many values, and we substitute them in. The tricky part here is making sure we follow order of operations, parentheses first, and then exponent. So we do 15 squared before we do anything else, and get 225 there. Then we can multiply by 2 pi, and we do 2 times pi times 15 times 3 separate. So if I were to combine everything, I get 90 pi over here, and 225 times 2 will give me 450 pi over here. I haven't multiplied by pi yet because I want to keep it as exact as possible. Now, just like having variables, I can add 450 plus 90 for 540 pi. And if I multiply 540 by 3.14, I'll end up getting an answer of 1,695.6. And this was centimeters, so centimeters squared. Let's look at example B. We have a radius of 4 and a height of 6. We follow order of operations. We take 4 squared, times that by 2 to get 32 pi. 2 times 4 times 6 would be 48 pi, for a total of 80 pi, inches squared, and then 80 times 3.14, 251.2 square inches. There's the basics. Now let's look at it in a word problem form. A cylindrical soup can is 7.6 centimeters in diameter and 11.2 centimeters tall. What is the area of the label that covers the side of the can? Now remember, in a soup can, the label doesn't cover the entire can. It leaves the circle parts open, and the circle parts are the bases. So we are just looking for the middle portion, which is the lateral surface area. So when we're looking for the lateral surface area, it comes from the formula for everything, but we're not looking for the bases. So we eliminate the portion of the formula that talks about the bases. So this portion, the perimeter times the height, would be the lateral surface. So we need the radius and we need the height. Because we have a diameter, we cut it in half for the radius to be 3.8 centimeters. The height is 11.2, so 2 times pi times 3.8 times 11.2 is approximately 267.3 centimeters squared. A cylindrical storage tank that is 6 feet in diameter and 12 feet tall needs to be painted. The paint will cover 100 square feet per gallon. How many gallons will it take to paint the tank? Well, first we need to know the actual size. So we're going to start by finding out what the surface area is. Since it's a diameter, we need to cut it in half, so 6 becomes 3 feet. Substitute 3 and 12 into the proper places. Take 3 squared times 2 pi times 3 times 12, add them together. You get 282.6 feet squared. The paint will cover 100 square feet per gallon, so we divide this by 100. So we need 2.826 gallons to cover the tank. That's it. Make sure your notes are filled out completely. On the left-hand side, write questions that could be answered. You could write about the formulas, you could write about the shapes that we're identifying. Review your notes, eliminate anything that wasn't as important as you thought, highlight and underline the things that you're going to use over and over again, and complete the summary before class.